Imagine that this is the sun. And imagine this rock is planet Earth. I guess that most people would assume that the Earth goes round the sun over a year in a broadly circular orbit. Kind of nice and symmetrical. But the orbit is actually slightly elliptical. It's more of an oval. I'm exaggerating it for effect. Now, over long periods of time, that ellipse gets more and more skewed. It gets stretched out to be even more oval-shaped.
All this stretching is caused by the gravity of the other planets pulling the Earth out of position.
Now, the thing is, when this happens, the Earth spends more of its orbit away from the sun than it does towards it. Winters that happen when the Earth is out here at its furthest distance tend to be more intense. And this position, furthest from the sun, the most stretched orbit, comes around every 100,000 years.
Croll took into account other factors which also change over time, such as the tilt of the Earth. When these coincide with the most extreme orbit, the winter temperature of the Earth is at its lowest, 20% colder. Sounds a lot, but it's still not enough to unleash a full-blown ice age. Croll believed there had to be something else to make the Earth even colder.
This beach has become a bit of a science lab. There are two sets of different ice cubes here. Same size, but slightly different colours of water. This one here is your regular water, so it's transparent, it's clear. But this one has a tiny amount of black dye in it. Now all I need to do is keep them out in the sun to melt. What Croll did was apply the simple physics of reflected light to the Earth's climate. It's something we all know, that light-coloured surfaces reflect more sunlight than dark ones. So what should happen is that these light-coloured transparent ice cubes should reflect off to bounce off more of the sun's energy and take longer to melt, whereas these darker ones will absorb more of that heat and melt much quicker. Well, that's a theory. Look at that. All of the ice is gone from the black one. And then there's what? 1, 2, 3, 4, 5, 6 ice cubes still left there. Ah! I'd call that a success. The ability of light surfaces to reflect heat is called the albedo effect. I don't suppose there's too many janitors that would have wondered about the effect of that on the Earth's climate.
Think of the clear ice cubes as the ice sheets at the North and South Poles. Croll argued that every 100,000 years, the extreme orbit of the Earth triggers the growth of these ice sheets. The more the ice expands, the more heat from the sun is bounced away. The more heat's reflected, the colder the Earth gets, and yet more ice grows. Eventually, it covers much of the Earth. In an ice age, it can last tens of thousands of years.